this particular section, we're going to be talking about sample size and power analysis. So why do we consider sample size to be very important? So first of all, when you're trying to conduct a good research, sample size is not just a number. It's actually one of the very, very important factors of your research. In terms of scientific validity, can your study detect real effects? So your sample size will let you know that if your study can detect real effects. Also, ethical responsibility. We don't want a situation whereby a researcher will be wasting resources or participants' time. Conduct a research and you find out that you found no real effect or no significant effects. That wasting both study resources, a lot of money, or researchers' time. Also, resource allocation. The time, money, and personnel that's going to be spent on the research also is very, very important. Even publication success. And underpowered studies often fail peer review, maybe due to small sample sizes. When your sample size is too small, you miss real effect. When it's too large, you waste resources, because sometimes with just smaller sample size, you can get the results of when you use a higher amount of sample size. So this is one of the reasons why sample size calculation is very important. So some of the real world consequences of underpowered studies: you actually waste research funds and participant time after conducting the whole study, and you also get false negative. That means you miss real treatment/effects. This is whereby you accept the null hypothesis when it's not actually true. You also make definitive conclusions, and your research or your study might not even get published due to the study being underpowered. Also, when your study is overpowered, whereby you are supposed to have used a smaller sample size instead of a large sample size you use, and also you detect trivial effects as significant. An effect that might not even be large, you might end up detecting it as significant. And also ethical concerns, because you have used a lot of participants more than what you actually need. So this is why in study or in research, sample size calculation is very, very, very important. So what determines your sample size? First of all, is effect size. How big is the difference you expect? And also your significance level. Usually 0.055% false positive rate. So first of all is your effect size. How big is the difference you expect? What is the difference you're trying to expect, and how big is it? So you also have the significance level. So your level of significance, probability of you rejecting a true null hypothesis. So imagine there was no actually significant difference between what you are studying in your research, and you now find out there was a significance difference. So you have rejected a true null hypothesis. So the probability of rejecting a true null hypothesis is usually given as 0.05, so 5% false positive rate. So statistical power is opposite of level of significance, with probability of rejecting a false null hypothesis, and usually given as 0.80, the chance to detect real effect. So also the variability, how spread out is your data. So if you have any of these three, then you can be able to get the other one. If you have effect size, if you have effect size alpha 1 minus beta, you can get variability. Likewise, if you have significance level, statistical power, variability, you can get what? Effect size. So after already finding out whether the relationship between what you are studying is significant or not statistically significant, you need to determine the effect size. So effect size of 0.2 means subtle difference, while an effect size of 0.5 is a noticeable difference, while a large effect size of 0.8 is an obvious difference. So where do effect size come from? Effect size usually come from previous literature, pilot studies, clinical significance threshold, and also expert opinion. So by the time you want to calculate your sample size, or maybe the power of your study, then you can get effect sizes from previous literatures that have already been used or calculated. You can get it from pilot studies, or clinical significance threshold, or even expert opinion. So these are sources where you can get your effect sizes from. So sample size planning. So this is typical scenario now, whereby the research question is saying if a new drug lowers blood pressure more than the placebo. Now, the expected difference from the pilot data was 10 millimeter mercury. This was the expected difference, while the standard deviation from literature was 15 millimeter mercury. So your effect size is now going to be what? The ratio between the expected difference and the standard deviation, which is 10 divided by 15. Then you have 0.67. Then you now set your alpha to 0.05. Then you now set your power to 0.8. With this information, you can use it to calculate your needed sample size to answer your research question. So this approach prevents guessing sample sizes. So sample sizes need to be calculated statistically instead of guessing them, because they are very important. We don't want the situation whereby we use a small sample size and we get an underpowered study, so we'll go and use a large sample size, whereby a small sample size will have been sufficient for us to achieve the answer to our research question.